The FV4601 MBT-80 was a British experimental third-generation main battle tank, designed in the late 1970s to replace the Chieftain tank. It was eventually, and later controversially, cancelled in favour of the Challenger 1, itself an evolution of the Chieftain design. History. By the early 1970s, there was great disparity in the number of tanks being fielded by NATO and the Warsaw Pact in Europe. Plans to develop a joint main battle tank for both West Germany and the United States, the MBT-70, failed after conflicting requirements for the tank and cost overruns. Looking to replace the M48 Patton and Leopard 1, West Germany cooperated with the United Kingdom to develop a future main battle tank, FMBT. This was expected to replace the UK's Chieftain tanks starting in the 1980s, as well as the older West German tanks. In 1977, Frederick Muley, then Secretary of State for Defense, announced that, while both countries had agreed on the specifications of the joint tank, the replacement timetables diverged to such a degree that collaboration was not practicable at that time. Still looking for a Chieftain replacement, the UK then considered importing XM1, later M1, hulls and turrets and combining them with British-made components such as engine, transmission, and a rifled 120mm gun on a domestic production line in order to produce a new tank. Ultimately, however, the UK instead officially began development of the MBT-80 in September 1978. This new project would build on work already carried out by the Military Vehicles and Engineering Establishment, MVE, as far back as 1968, when they had produced a tank prototype with an external, in other words unmanned, turret. This was followed in 1978 by another tank prototype fitted with Cobham armour. This later prototype was based off the Chieftain design, and had the designation FV4211. Design. The MBT-80 was designed to counter all then current and future armoured threats from the Eastern Bloc, combining a rifled gun, advanced composite armor and increased mobility onto one platform. Other design features included the use of a David Brown Gear Industries TN38 transmission, a Sperry/Vickers stabilized panoramic sight for use by the tank commander, and an advanced Vetronix suite incorporating Ferranti F100L microprocessors. The MBT-80 would have also been the first operational British tank to have a crew compartment with a full environmental system, i.e. able to provide both heating and cooling for the crew. Armament. The primary armament of the MBT-80 was to be a 120mm rifled gun, the EXP-28M1, similar in some respects to the main guns found on the Chieftain and later the Challenger 1 and Challenger 2 main battle tanks, but a new design in its own right. It was an advanced development of the L11 tank gun, designed by the Royal Armament Research and Development Establishment, and utilizing a split-block breech mechanism. It was one of the first tank guns to use an electroslag refined steel barrel. This new barrel was intended to greatly increase the fatigue life of British 120mm tank guns. The technology had been cleared for use by new tank gun designs in 1976. The fire control system was able to access and process relevant target, environmental and gun status data from various internal and external sensors including laser rangefinders and thermal imagers in order for the main gun to be able to accurately and consistently hit targets under the most adverse of conditions: first shot, first kill. Major components of the FCS included the fire control computer, which was the brains of the FCS, the gun control equipment, and the Stamplar sight, see below, all of which were connected together by a fully digital database. The FCS was also designed with self-diagnostic capabilities. The commander and gunner had duplicate turret/main gun controls, so either of them could aim and fire the main gun. Ammunition for the EXP-28M1 would have included APST, APDST, heat, HESH, and smoke WP rounds. Secondary armament would have included a 7.62mm L37A1 general-purpose machine gun mounted on the commander's cupola, which could be aimed and fired from within the tank. L2A1 ball and L5A1 tracer rounds would have been among the ammunition available for this weapon. Protection. The MBT-80 was going to be primarily protected by the recently developed Cobham armor, first fielded on the American M1 Abrams. The armor would have provided greater resistance against high-explosive anti-tank, heat, rounds and kinetic energy penetrators. Thanks to the use of Cobham armor, it was anticipated that much greater use could be made of high-grade aluminium alloy in the construction of the hull, turret was steel, than in previous tank designs, helping to keep down the overall weight of the tank and therefore improve mobility and associated logistics, not to mention transportation of the tank to where it would be needed. The tank would also have had, among other protection features, a full active NBC suite, something that was becoming more common on military vehicles being designed and/or introduced in the late 1970s and early 1980s. This included both advanced NBC sensors and radiation/M, including EMP, shielding to help protect the crew and vehicle systems. An extensive electronic warfare system including a dedicated ECCM capability was also to be included. This system would have incorporated various countermeasures against such threats as RPGs and first through third generation anti-tank missiles. As a thermal signature management measure, the exhaust gases from the Rolls-Royce CV12 TCA Condor engine would have been mixed with cooling air prior to being discharged outside the tank. This particular feature was also used on the Vickers Valiant MBT. Mounted on the sides of the turret would have been two L8A1 6-barreled 66mm smoke grenade dischargers, identical to the M250 grenade launchers found on early models of the M1 Abrams. Mobility. The MBT-80 was to have a longer range, more mobility, and greater speed than previous tanks. Two options were considered: the Honeywell AGT-1500 gas turbine engine used by the United States' prototype XM1 Abrams tank, producing 1,500 HP, and a modified, turbocharged version of the Rolls-Royce CV12 diesel engine, also producing 1,500 HP. The CV12 was eventually picked, primarily due to the fact that the AGT-1500 would require substantial modification of the tank to suit the associated transmission that came with the engine, which had been specially designed for the XM1. The higher fuel consumption of the gas turbine engine was also a factor in choosing the diesel engine. The CV12 was expected to be produced at Rolls-Royce Shrewsbury plant. Sensors. Known sensors included: Sperry/Vickers stabilized sight for tank commander, daytime sight only with x1x10 magnification. Panteley, panoramic, thermal imager, laser integrated sight, 360-degree rotating thermal imager fitted with a CO2 laser rangefinder. Accessible to both commander and gunner. Similar in concept to the hunter-killer sight found on the later Challenger 2 tank. 2-axis stabilized monocular gunner's sight incorporating a laser rangefinder and muzzle reference system, magnification x2-3 and x10. Backup telescope with x8 magnification also provided. Driver's thermal imager, possibly the Bar and Stroud IR-18 TVFS, but this is unconfirmed. The IR-18 was later used as part of the Challenger 1's TOGS, thermal observation and gunnery sight, system. Stamplar, sight, thermal, armored, periscope, laser rangefinder, part of the fire control system. Directly tied into the fire control computer via a digital databus. Roof-mounted infrared detector, part of the NBC defense suite, it could detect airborne chemical agents and radioactive fallout. Later available as an option on the Chieftain 900 tank. Versions and variants. Among the projected vehicles based on the MBT-80 chassis were a SPOG using the turret of the Flak Panzer Gepard, and an ARV. None of these had progressed beyond the concept stage at the time of the program's unexpected cancellation. In the aftermath of the Iranian Revolution, all orders for weapons from the United Kingdom were cancelled, including those for Sher 2 tanks. The British defence industry was heavily reliant on the Iranian market, forcing the government to cut the number of workers at ROF Leeds. At this same time, the government was looking into how they could still retain the skill and capacity at Leeds that would be needed to produce the next generation of main battle tanks. Despite attempts to put the tank into production as quickly as possible, it would not be until the mid-1980s that the MBT-80 would be ready for production, even if development was drastically accelerated. In addition, there were increasing worries that Soviet tank technology was advancing at such a rate that new designs reportedly about to enter service would render existing frontline British MBTs obsolescent much sooner than had been previously predicted. Ultimately, the entire program was cancelled in favour of the Challenger, which had been developed from the Sher II as a private venture, and would be in theory available for service by 1983 to replace the Chieftain tanks instead. With its adoption as an official program, the Challenger was also known for a time as the MBT-85. However, various research elements of the MBT-80 program were continued in order to develop and mature advanced technology for the next generation of British MBTs to enter service in the early 1990s, the design of which was to be provided by the new MBT-95 program, launched in late 1982. In the event though, the MBT-95 was superseded by the Challenger 2 program in 1987 in part due to financial and political considerations and partly due to the unexpectedly poor performance of the original Challenger in early trials, exercises, and the like, which seemed to indicate an urgent need for a replacement tank in the near term, and not just to replace the remaining Chieftains as originally planned. However, the Challenger 2 was not officially chosen as the British Army's new tank until late 1991, by which time most of the Challenger 1's problems had been resolved more or less, albeit at an extremely considerable cost in time, money, and effort, with it having racked up a generally enviable operational record in the just concluded First Gulf War. In a twist of irony, had the MBT-80 being allowed to proceed along its originally planned program schedule, not to mention its proposed acceleration, development to be completed in 1987 rather than 1988, it would have finished development and been well in production by its intended in-service date of 1989. This was in stark comparison to the Challenger tank at the same point in time, which, despite having been in production for nearly 7 years and officially in service for over 4 of those, was widely considered to be still not fully operational due to a range of woes ranging from an infamously deficient fire control system to a main gun, basically exactly the same gun as on the Chieftain, which was rapidly approaching retirement, that was seen as having become dangerously obsolescent. Surviving vehicles. 2 test rigs were built to test the various systems that would be used in the planned MBT-80. The first, Automotive Test Rig 1, ATR-1, had a hull assembled from Sher II prototypes derived from the Chieftain, removable blocks of armor that either contained cobham or steel designed to imitate it, and a dummy tank gun. It could also move under its own propulsion. ATR-1 fell into the hands of a private collector but is currently in bad condition. The second rig, ATR-2, was designed to test the ability to weld aluminium and steel tank hulls together to reduce weight. It also had a different turret design from the ATR-1 and possesses advanced sights that were state-of-the-art at the time of construction. ATR-2 is currently displayed in the Vehicle Conservation Centre of the Bovington Tank Museum in Dorset. Type: Main Battle Tank. Place of origin: United Kingdom. Service history: in service 1989, planned. Production history: designer military vehicles and engineering establishment. Designed 1979. Manufacturer ROF Leeds, planned. Unit cost £1 million sterling estimate, September 1978. No built 2 prototypes, ATR-1 and ATR-2. Specifications: weight 55 tons empty, 62 tons fully loaded, crew, fuel, ammunition, armor package, etc. Crew 4, commander, gunner, loader, driver. Armor: cobham. Main armament: RARD EXP-28M1 120mm rifled gun, split block breech. Secondary armament: RSAF 7.62mm L37A1 GPMG fitted to the commander's cupola. Engine: Rolls-Royce Motors Military Engine Division CV-12 TCA Condor 12-cylinder diesel. 1500 HP. Power/weight 27 bhp/t. Transmission David Brown Gear Industries TN38 Transmission, automatic. Suspension Hydropneumatic suspension, similar to the later Challenger MBT.
Please subscribe and thanks for watching.